High-speed running and sprinting are very important movements for most team sports. Therefore, a lot of research has been done to understand the biomechanics of these movements and therefore how we can improve performance in them through strength training. Some very interesting research has measured the key mechanical variables at each joint at a range of steady-state running speeds, including sprinting. And this type of research gives us two key insights. Firstly, it helps us understand which of the muscles, which of the joints and which of the muscles are most important at each point in the sprinting or running gait cycle. And secondly, it helps us understand how each of those muscles change their involvement as running speeds get faster. And together with these two pieces of information, we can understand what actually drives high-speed running and sprinting performance. This first study allows us to understand the relative contributions of each of the lower body joints to total lower body power in the stance and the swing phases of running and also sprinting. And it allows us to understand how that contribution might differ depending on whether the power is being generated or whether it's being absorbed. And as the chart shows, in the stance phase in which power is being generated, the ankle is the primary contributor. Whereas in the stance phase while power is being absorbed, then most of the joints are contributing a similar amount. In the swing phase, while power is being generated, then the hip is almost entirely responsible for all of that power generation. Whereas in the swing phase when power is being absorbed, then the knee is almost entirely responsible for that power absorption. And this tells us a lot about what is actually happening during the sprinting gait cycle. The hip generates power at 2 points in the swing phase. It generates power at the very beginning of the swing phase when the hip is flexing, and it generates power at the end of the swing phase when the hip is extending. And because the hip is generating power, it does this while the muscles are shortening. So we can say that the muscles that are involved at these two key points in the swing phase are the hip flexors at the beginning of the swing phase and the hip extensors at the end. Power is absorbed by the knee at two key points in the swing phase. It's absorbed at the beginning of the swing phase while the knee is flexing, and it's absorbed at the end of the swing phase while the knee is extending. And since the power is being absorbed rather than generated, it's the active lengthening of the muscles that are contributing to this power absorption. So it's the knee extensors, the quadriceps, that are involved in absorbing power as the knee is flexing in the early part of the swing phase, and it's the hamstrings or the knee flexors that are responsible for power absorption at the end of the swing phase while the knee is extending. This next study looked at the specific work done by each of the joints at different points in the gait cycle within the swing phase and within the stance phase. So this allows us to look at the work done in the initial and terminal parts of the swing phase and understand how that might relate to running and sprinting performance. So this chart shows the way in which positive and negative work done by the hips during running changes with increasing running speed. So running speed increases towards the right-hand side of the chart. And as we can see, the red and yellow lines, which are the positive work done by the hip, increase quite markedly with increasing running speed. Whereas the green and orange lines, which represent the negative work done, don't increase by quite as much. And we can also see that the work done at the end of the swing phase, in the red line, increases more than the work done at the start of the swing phase, which is the yellow line. And that means that overall, the positive work done by the hip is more closely related to increasing running speeds than negative work done by the hip, which we knew already, but now we know that the positive work done by the hip extensors at the end of the swing phase is probably more important than the positive work done at the start of the swing phase, which is done by the hip flexors. This is a similar chart, but for the knee muscles. Again, the red line refers to work done at the end of the swing phase, and the yellow line refers to work done at the beginning of the swing phase. But in the case of the knee muscles, this is negative work done rather than positive work done. And we can see that both the red and yellow lines increase with increasing running speed. But again, the work done at the end of the swing phase seems to increase by more than the work done at the beginning. So the role of the hamstrings in absorbing energy seems to be more important than the work of the quadriceps in absorbing energy, at least in the swing phase of running. And we can also see that the stance phase variables, represented by the blue and green lines, don't tend to change that much as we increase running speed. So contrary to popular belief, the knee role during the stance phase of running and high-speed running and sprinting isn't really as critical as it is in the swing phase. Putting all of this together, we can see that at the start of the swing phase, the hip flexors are doing work and producing force, and the knee extensors are absorbing that. At the end of the swing phase, the hip extensors are doing work and producing force, and the knee flexors are absorbing that. Then, as the foot hits the ground, it's the role of all of the joints together to absorb the impact forces, but then it's the role of the ankle to lift the body centre of mass back up again as the gait cycle progresses. Then the cycle repeats itself and we start the swing phase again. It might seem strange that it's the joint powers and work done in the swing phase that are closely linked to increasing running speeds rather than powers and work done in the stance phase when we're actually in contact with the ground and able to propel ourselves forwards. But what this probably represents is a proximal to distal sequencing of joint actions, such that kinetic energy is originally produced at the hip and then transferred to the knee and then onwards to the ankle at the point of ground contact. So it's the force and work done by the hip at the end of the swing phase that is then absorbed by the knee just prior to ground contact, which is the actual driver of running performance rather than the joint work or muscle forces produced in the stance phase itself by those same joints.